Hello everyone. I hope you all are following the rules of lockdown and keeping yourself safe. So let's talk about this new video. This video is related to continuity, chapter 5, class 12th. This is part 2 of continuity. Why am I using part 2? Because my previous video was also related to continuity. In that video, I discussed with you what is continuity, okay, as well as the test of continuity and few of the examples. Now in this video I am going to discuss with you the algebra of continuity. Again, I request all of you, if you haven't seen my previous video yet, then you just go and watch it, because it's very necessary for you to know what is continuity as well as the concept of continuity test. Then only you will be able to understand the next video. Okay, so I am going to share the link of that video in the description box, so you can click and watch it then and there. Okay, so let's start today's lesson, that is continuity, algebra of continuity. Algebra of continuous function. What is algebra? Whenever this word comes in front of our eye, the first thing that clicks, that is addition, subtraction, multiplication as well as division. So here we are going to talk about algebra of continuous functions. So what about continuous functions and algebra? So what kind of results are we going to obtain through that? So this is what we are going to study. So what is that? Let f and g be two real functions. Real functions means real valued functions. Okay. Continuous at x equals to a. This is what we are going to consider, that f and g are two real valued functions and both of these functions are continuous at x equals to a. And c be a real number. C is any number that is real in nature. Now what sort of result are we going to get? The first result is the sum of these two functions will also be continuous at x equals to a. The difference, here it is sum. Now the difference of these functions will also be continuous at x equals to a. The third one, if we multiply the real number with function, then that combination will also be continuous at x equals to a. Fourth is the multiplication of both the function f into g will also be continuous at x equals to a. If f is continuous at x equals to a, then our fifth result is 1 upon f will also be continuous at x equals to a, provided fa not equals to 0. That condition is obvious condition, that denominator should not be equal to 0. Okay. Now last result, f upon g, that is the division, will also be continuous at x equals to a. Condition is applied that GA, it means again the denominator should not be equal to 0. So these are the results that we are going to obtain. Now I am going to take one of the result. I have chosen the second result to prove it. Almost the proofs are similar. So if you know one of the proof, you can prove any of these result. Again, I request all of you that I am going to solve only one of them for you, but you solve all the results by yourself. Okay. So let's start that. We want to prove that if f and g both are continuous function at a particular point, that is a, then we have to show that the difference of these function will also be continuous. So since f and g are continuous functions at x equals to a, if you remember in the last video we discussed with you that what is the meaning of continuity. If we say that the function is continuous at x equals to a, this is what we are talking about. Then what is the meaning of this? It means that limit of that function at that particular point. What is that point? A. It means fx. That will be equivalent to the value of the function. Okay. if you remember, we considered 3 points. Left hand limit equals to right hand limit equals to the value of the function. So it means the limiting value of that function should be equivalent to the function value. This is the rule of continuity. If we say a function is continuous, it should follow this. So just keep this result in your mind. Then only you will be able to understand it very conveniently. Okay. So as we are saying that f is a continuous function at x equals to a. If it is continuous, it means its limiting value will be equivalent to the function value. So this is what we have written here, that limit x tends to a, fx equals to fa. Okay, clear? We are saying that g is also continuous at x equals to a. Therefore, we can write that limit x tends to a, gx is also equivalent to ga. Now what we want to show? We want to show that f minus g is continuous. Okay, it means what are we going to show? We will show that limit value of f minus g at x tends to a is equivalent to the function value. Okay, if we are able to show this, it means our work is done. How we will show? This is what we are going to take under consideration, that limit x tends to a, f minus gx. According to the rule of the limit, we can separate this limit that you studied in class 11th. So if we separate, we will get this line. Limit x tends to a, fx minus limit x tends to a, gx. Okay. Now with the help of this result, in place of this limit, we can write fa. And with the help of this result, in place of this, we can write ga. So this is fa minus ga. And this can be written as f minus ga. Okay. So we took this one and we got this one. It means limit value is equivalent to the function value. So we can conclude that f minus g is continuous at x equals to a. This is very easy proof. So with the help of this proof, you can prove any of the result that was obtained in the last slide. Okay. So just try it. Then only you will be able to understand it clearly. Now just see few of the examples. This is one of the example. Find the value of k so that the function f defined below is continuous at x equals to 0. The function is defined in this way. For x not equals to 0, the function definition is this, and for x equals to 0, the function is k. Now how to solve it? They have said in the question that f is continuous at x equals to 0. So you know very well, if the function is continuous, then the limit value is equivalent to the function value. So obviously we are going to use this result. Okay. So left hand limit equals to right hand limit equals to function value at 0. And what is function value at 0? That is given, that is k. So what we are going to do, we will consider this condition. We will calculate one of the limit RHL or LHL, and we are going to put it equivalent to f0. Is it clear to you? Now just calculate the left hand limit. Okay. So limit x tends to 0 minus, obviously I told you in the last video that for the left hand limit we write 0 minus fx. So that can be converted into this. Now for x less than 0, the function is this. So we are going to write this function as cos is an even function. So the negative will be equivalent to the positive. So minus 4h will be 4h. So 1 minus cos 4h upon 8h square. Okay, is it clear? We are simply putting. Now what we are going to do, if you just see it clearly, 1 minus cos 4h. So cos 4h can be broken. How? You know very well that cos 2x is 1 minus 2 sine square x. So if you are going to make it 4x, then this will become 2x. So 1 minus 2 sine square 2x. So this is what we are going to use. Okay. So just see in the next slide. So we have used this one, and after that 1 and 1 will be cancelled and you will get this result. Now in the last video only I told you that you have studied in 11th standard, that limit h tends to 0, sin h upon h is what? 1. Okay. So here sin square 2h and here 8h square. So we can break it in this way. So now sin square 2h upon 4h square. So this will become 1. Now what is left? 2 upon 2, that is nothing but 1. So left hand limit, that we got 1, and function value at 0 was also k, that I told you. So by considering these two values, we can write that k is equivalent to 1. Is it clear to you? This is very easy example for you. Okay. And on the basis of this example, you can solve many of the question of your NCERT. Okay. And if you have any problem, you can post it to me. Now the next one more example is there for you. Discuss the continuity of the function given by fx equals to mod of x minus 1 plus mod of x minus 2 at x equals to 1 and x equals to 2. Again, example is very easy. You just try to see. What is difficult in this? First of all, you just define the function. Mod x minus 1 plus mod x minus 2, just break it. If x is less than 1, then obviously mod of x minus 1 will be negative of x minus 1 and mod of x minus 2 will be negative of x minus 2 according to the definition of mod. You know very well, mod x is x for x greater than equal to 0 and minus x for x less than 0. So we are using that definition. If x lies between 1 and 2, then this will be positive x minus 1 and x minus 2 will be negative. Okay. And if we consider x greater than equal to 2, it means both will be positive. So just solve them and you will get this function. Minus 2x plus 3 for x less than 1, 1 for if x lies between 1 and 2, and 2x minus 3 for x greater than equal to 2. First of all, you define the function well. Again, keep the copy and pencil in your hand and just do it. After getting this, the question is very ordinary, very easy question. So you can see. Now we want to check the limit, the continuity at x equals to 1. So limit x tends to 1 minus fx. That will be obviously for less than 1, the function is minus 2x plus 3. So just put it and you will get the result 1. For x tending to 1 plus, more than 1, your function is 1. So that will be equivalent to 1. So f1 equals to 1. Okay. If you remember, then we have defined in the last slide 2x plus 3 for x less than 1. And for x lying between 1 and 2, the function value was 1. So this is what we have written and we obtain f1 equals to 1. So f is continuous because all the three results are equal. Then we can say that f is continuous at 1. Similarly, you people can try it at x equals to 2 by your own. Okay. So if you have any query, if you have any problem, you can ask me. Thank you so very much.